Hey class! Today what we will be going over is the conceptual massing environment. The conceptual massing environment is the freeform modeling part of Revit. It allows you to work with just pure geometries, and it's a little bit more manipulative, working in more like a 3D massing environment. Uh, it's relatively similar to SketchUp. Not so much. I mean, it does the same kind of geometrical manipulations as Rhino, but the interface is a little bit more like SketchUp. But the nice thing is that you can take those geometries, the massings from the conceptual massing environment, and apply them directly to actual Revit elements, and use it as a base. So we'll be going over just the basics of it, and then for your assignment this week, you'll be creating an actual architectural piece from it. So to get started, let's just do what we have always been doing. A couple of you have run into this mistake by accidentally opening your Revit template instead of creating a new project with the Revit template. So please be aware of hitting new first, okay? Do not open the actual Revit template, because then you'll be changing the template, which you don't want to change because it's a template. It's your starting point. So make sure you're creating a new project from the Revit template, okay? Hit OK, let it open up. And to begin with the conceptual massing environment, we'll start with a pretty simple project. And I'll use Ally Charlotte Center as a reference. It's pretty typical. Probably wouldn't use a conceptual mass for it, because it's a rectilinear mass at a certain height. But once we get that mass, we'll start to do a little bit more manipulations to it that wouldn't be possible without the conceptual massing environment. So first, what I want to do, I want to delete the roof, and then let's put level 2 at 20 feet. Oops, just kidding. Put the level 2. So remember, click the level and then click the elevation. Type in the new one. You can also manipulate it over here on the type properties. All right, 20 feet, 18 to 20 feet, typical retail floor-to-floor height. And then the next, we're going to create 26 levels. That's how tall Ally Charlotte Center is. And to do that, we're going to use that array tool again. We went over it last time, so I won't get into too much detail. Let's just say 15-foot floor to floors, which is pretty typical for an office building. Since we already have the one, let's do 25. Okay, that's good. And then let's change the name of this. Remember, ungroup. Change the name to roof level. All right, now we have our building. Now we have our building. Now we have our levels laid out. So what we want to do is go into a 3D view. And if you have 2019 and 20, you should be able to see these. If you have 2018, it's okay. What we'll do now is go into the Massing and Site tab up at the top. That's where you will find your conceptual mass window. I'm going to have to take away the squeaky toy from my dog. One moment. Okay, squeaky toy taken. All right, up at the top left under Massing and Site, we have our conceptual mass. Now you can do one of two things. You can model in place. That is the InPlace Mass. That means that you'll actually model the geometry directly in your project. Or you can actually open up a new project, a new conceptual mass project. Create a conceptual mass in a completely different window. It's essentially a family. And then you can import it and place it just like you would a piece of furniture. Acts the same way, but I like doing the InPlace Mass because then you can have the the environment of which your project is in to reference. It's nicer for me. So this is how you start. You do InPlace Mass, just click it, type in a name. So I'm just going to say ACC for Allies Charlotte Center. Press OK. All right. Then it's going to gray out, and you're going to have these new drawing tabs, these drawing tools up here. The 2D drawing tabs are what you're going to start off with. You're essentially going to draw, just like you would in Rhino, a 2D line work to then create 3D form from. So what I'm going to do is I'm going to go to level 1, and I am going to draw a rectangle. So up here under the draw group, just grab a rectangle, drag and drop, and then I'm going to go in and tab to get one of the lines. Type 120, and then tab again, 240. That's your very typical office dimensions. One of your more efficient floor plates. All right, and then if I go back to the 3D view, so we have the outline, the profile, section profile, plan profile, footprint of our building, and then what I can do. So if you select that line work, you can then get this form generator button, toggle, whatever, up at the top. And it's going to create a form from the 2D line work. Now, depending on what type of line work and how it's oriented, the type of 3D geometry that's produced is going to change, right? So this is a closed curve. So it's going to create a solid form, and it's also a closed planar curve. So it's going to extrude it perpendicular to its plane. And that's what we want. So we can go up and we can either type in our height, or we can just go to a side view and drag it up to the top. All right. Now, let me just review a couple things really quick. So if we drew just a plane, right, and then hit the create form, that's just going to create a plane. It's pretty straightforward. If, let's say, we draw a circle, hit create form. So that's going to prompt us, right? So down at the bottom, and these the location of these may change. So for some people it might be up here, for some people it might be on the left. But if the 2D line work that you've drawn can produce multiple types of geometry, like for example, this circle can produce both a sphere, which is this guy, or like an extruded cylinder. And you get to then choose which one you were trying to accommodate from. So sphere is now created. Now it still breaks it in halves because the geometry in Revit is still pretty basic. And it also sets it up for Revit elements in the future. So it's a little bit more process driven, how they actually break down the geometry. But so just be aware. And if you are ever trying to create a certain geometry and you can't get it to work quite right, either reach out to me, do some Googling, and we can figure out the best way to do it. You can also, and I'll show you later on in the class, how to take a Rhino geometry and import it into the Revit environment and start to manipulate it there. But for stuff like this, it's pretty good. So right now I have my 120 by 240 footprint. It's all the way up as tall to the roof level. And now I have my base. What I want to do is I want to show you what you can do with a conceptual mass. So up at the top, I'll want to finish mass. So once you finish, you are out of the editing environment, your windows go away, and now it's just one solid geometry that you can move around. Depending on the geometry, you can also manipulate its size outside of the conceptual mass environment. I typically don't like to do that. Depending on what type of geometry you have and how complex it is, it might not do exactly what you want or be as specific as you want. But for what we're doing, we'll just keep it the same. All right, so there's a couple things you can do with the conceptual mass. The first thing that you can do, and especially with tower masses, is you can create what's called mass floors. And what mass floors are, so if you select the conceptual mass, up at the top, it'll give you this prompt. You can either go back into the conceptual mass editing environment, which we were just in, or you can create mass floors. What mass floors does is if you select it, it will give you all of the levels within the project. And then if you check certain ones, it will essentially slice through the mass and give you a floor profile, a floor plane. So if we hit OK, you can see that we now have the mass floors under all the floors that we selected. And then what you can do from there is go under architecture, go to the floor tool and do the drop down. And instead of hitting floor architectural, we'll do floor by face. And then you can go and select those mass floors that you just created and select the type of floor that you want. So let's just do generic 12-inch for right now. And then once you have the desired mass floor selected, you can hit create floor and it'll actually create the floor around that geometry. Now, you're probably saying, why would we waste time doing conceptual mass and do all these floors? They're just simple rectangles, right? And I totally get it. It's when you start to get a really complex geometry is when you want to use this. And the nice thing about these and the corresponding mass elements, which I'll show you, is that they're all updatable if you start to manipulate the mass, right? So if I go in here and I drag this out, the mass floors update to the geometry, and then all you got to do to update the floor to it is select the floor and then up at the top hit update to face, and it updates to the geometry that you just did. And that, obviously if you want to grow the dimensions, but also if you want to start getting kind of technical with it. So if you do edit in place, I'll show you a couple different editing tools that you can use with the conceptual mass. So not only can you select the whole geometry, but you can also select you can select planes. So you can select this plane and start to move it and start to manipulate the mass that way. I'm just going to undo it to keep it somewhat regimented. You can also select edges and manipulate the form that way. Okay. You can also select points. So every time there is a intersection of edges, it'll create a point, and then you can start to manipulate it that way. And if you finish the mass, if you start to manipulate it, finish the mass, no matter how complex or weird or funky your geometry gets, your floor or your mass floors will always update to that geometry, and then you can update the floor to that face. Okay? So that's floors. Let's just select. Oh, and let me do this real quick. A little side note. I showed a couple of you how to do this, but I'll show the rest of you now. If you're getting sick and tired of tabbing through a million elements to get to what you want, you can, or if you want to like select one of or a multiple of one specific Revit element type, you can so click and drag and select all of these elements, And then when you have multiple different types of elements selected, what will pop up under selection is this filter tool. If you click that, it's going to show you all the different categories of the elements that you have selected, and you can go in and check or uncheck the elements that you want to actually keep selected. So I want floors. I hit OK, then I can update these all to the face, and I don't have to worry about going in and selecting each individual one and updating them one by one. Because especially if you have, all these floors, which actually, we'll do that right now. Let's go in, and if you click and hold Shift to select all of these in a row, and then press OK, and I just want to make sure, yep, select them all. Create mass floors for all of them, and then go in to floor again, do floor by face, and then you can just click and drag all and select all of the mass floors and hit create floor. Oh, and it's created duplicates in some of those areas. So I'm just going to go in to delete those. All right. So, oh, you know what happened? It doesn't matter. All right. So those are how to create floors from massing. Now, you can also do walls and roofs. So we'll start with roofs since that's a pretty simple one, and there's really only one thing that you can do with it. So you can do roof by face, and then you can select pretty much any face that isn't vertical, right? So if it points upward in any direction, you can apply it. So you could apply it to this face since it does turn from true vertical, but you can't select the other ones because they're purely vertical faces. So obviously we wouldn't want to select a roof on this one, but we would want to do it on the actual roof face. So we have our basic roof highlighted that we want to apply. Click, make sure it highlights in blue, and then up at the top hit create roof. And then that's the same principle as the floors. They will update if you go in. The roof itself won't update immediately. You have to go in and update the face just like you do the floors. All right. And the next thing that we'll show, so I just undid those couple moves, just to keep it somewhat simple, is walls. So it's the same exact way as your roof. Is do the drop down underneath the architecture tab, hit wall by face, and then this is when distinguishing between basic walls and curtain walls really become important, because a basic wall can be put and applied to pretty much every single kind of face except a completely horizontal one. So like these, the floor faces, the mass floor faces, it won't be able to apply to. But if we click all of the surrounding roofs, it automatically creates. It doesn't ask you to create face like it does with the mass floors or the roof. It just automatically does. So if I clicked all 4 faces, now I have a basic wall on all of those. And there's one thing to be aware of if we go into level 1 and zoom in. So the location of the placement line, we went over that a little bit in the first tutorial, where you have the center line, into your face, exterior face. So depending on where that is where it's going to align itself to the mass face, if that makes sense. So the center line of the wall, how do I explain this? The location line, wherever you determine it, is going to be where it aligns to the face of the mass. So if I say exterior face, it's going to align its exterior face with the mass face. If I say the center line or the wall center line, it's going to put the face of the mass in the center of the wall. If I say interior face, it's going to push the interior face in parallel with the mass face. Just play around with it to get a better grasp of of what we're where it aligns itself in relation to the mass. And then the other thing to remember, so if you, excuse me, if, let's say, you say interior face, whatever, and it's not aligning itself on the right side of the mass, right? Let's say I want the inside face to align and the wall to go inside the mass. All I have to do is hit the space bar and it will flip the direction that the wall is facing. So if I hit space, it won't do anything because, of course, why would it do anything? Oh, now it does it to that wall, but not this wall. It might be because this wall is so... Is it doing anything down here? I just want to see. No, it's not. So it might just be because this wall is so complex that there's only one direction it can face. But for this really simple vertical wall over here, if I hit space, it'll flip the direction that that wall is facing depending on where the mass face is. All right. So that's pretty simple. Same thing as before with editing the mass. And I'm just going to hide this real quick. I guess I'll go over that right now. If you want to like just temporarily hide something, what you can do is click whatever element you want to hide. Go down here to this sunglass or glasses. Click that and then just do hide element. And then it'll pop up with this kind of cyan outline that says that something in this view is temporarily hidden. So I've hidden that specific wall so I can easily access the conceptual mass. If I want to put it back, all I got to do is go down to the glasses again, reset the temporary hide, isolate, and it will return everything to normal. It's really helpful when you're trying to work on something and you still want it to be in the view eventually, but for the time being when you're working on whatever kind of element you are working on, you want it turned off. The other way to hide something, and a more permanent way to hide something, is to click the element, right click, hide in view, and just hit elements and it will hide it permanently. And the only way you will be able to get that back is if you go down to the reveal hidden elements button, this light bulb, click that. It'll go in this weird red environment and it'll highlight the elements that are hidden. Just got to click it, unhide element up at the top, or right click, unhide elements. That's back. All right, so we have done walls. Now, the other thing I want to do, and what I was talking about when we're distinguishing basic walls from curtain walls, is if you have a completely vertical face, you can apply a curtain wall system to a conceptual mass face, and we can do that now by doing the drop down, scrolling down, and just applying a curtain wall to that. Just hit unjoin, that's fine. And now we have a curtain wall on there. You can go in, you can, let's do storefront, let's see. Any of these have mullions already? Oh, yep. You can tell by how long it's taking to apply. And it's got a bunch of grids it's got to make. All right, and as you can see, if you have a curtain wall grid already associated with that curtain wall family, it'll apply that there. And for simplicity's sake, I'm going to put it back to curtain wall. And delete grid line. Yes. All right. And I'm just going to apply a really simple grid. I'm just going to do a fixed number and a fixed number just so we can see. Oh, don't give me cancel. Of course, it divides the same exact number because those came in from the other one. So I'm just going to turn this down to 6 and 6, see what that looks like. It's going to delete a bunch of grid lines. There we go. Okay. So the thing about curtain walls is they are only applicable to completely vertical faces. Basic walls can be applied to crazy complex double curvature or overhangs or underhangs or whatever. Curtain walls can only be applied to completely vertical surfaces. So if I tried to change this to the curtain wall, it's going to say error, can't do it. And it's just going to default to its original conceptual mass face. So right now there's no wall on that because it can't compute it. However, you know as well as I do that you can apply curtain wall glass systems to complex curvature, and you can do it like in the real world, and you can do it in the Revit environment, in the conceptual mass to a complex surface, but you have to use a different system. So instead of using a traditional curtain walls family that you find just in your typical wall family selection, what you got to do is go up to the top and select curtain system by face. So that is essentially taking the principles of the curtain wall and hello, Ray. Go lay down. Yeah. Sorry. Taking the principles of the curtain wall and changing them a little bit so that they can be applied to complex surfaces. So, curtain system, select it. And there's a 5x10 system that is already created. I am going to edit that, and I'm actually going to rename it to basic curtain system. And I'm going to change it to a fixed number, so we're not doing a bunch of, it's not taking a heavy load on the computer. And then let's do a 10 by 10. So these are just the equal divisions. So if you want to do a certain number of equal divisions across a face, this is how you do it. So it's going to do 10 divisions in the, technically the U direction and 10 divisions in the V direction. That's how it computes it. When they're subdividing surfaces, they don't say X and Y, they say U and V. It somewhat the same, but it's different, which I know doesn't provide any sort of clarity whatsoever, but you'll see what I mean. So 10 in the U, 10 in the V, hit create system, and now we have a curtain system, and I'm going to select it. And it's a little bit hard to see, but just make sure that the dashed line is around the entire perimeter. When you select it, make sure it's the curtain system that you want. And then what I'm going to do, just like you can temporarily hide something, you can also temporarily isolate it. So you can, and this is one of the things that there's a workaround for it in Rhino, but there isn't an actual command for it. And it's one of the nicest things, or nicer things that I like about Revit. Is that you can isolate an element to work on it. And this is very prevalent when working with curtain walls and curtain systems. So that glasses, once again, go down to the bottom, click the glasses, and then instead of hide element, isolate element. Now you can see that not only does it divide the surface, but it also responds to the change in geometry across the entire facade. And you can go in, and right now I don't believe that we have any mullions associated with it, but if we select that family, go to edit type, and then go down to the grid 1 mullions, grid 2 mullions, we can change that. So we can have, do a drop down, just do a typical 2.5 by 5 for each. So let's do a 1 inch square for the interior and 2.5 by 5 for the exterior. Same thing for grid 2. You know what? Actually, for grid 2, let's just leave out the interior types. Press OK. And then if you zoom in, you can see it's applied a 2.5 by 5 inch mullion on the perimeter. And if we zoom in, it's done a 1 inch square on grid 1, which ended up being the vertical grid. Let me click that and then click, I think this. Yeah, so, all right, let's do that one more time. Let me actually explain what I'm doing. So, it doesn't really tell you which grid is which to find, or it's not apparent. To find out which is which, you have to go in, select this configure grid layout, click that, and then up at the top, it'll tell you this grid is at 0, 1, but the thing to look out for up here, this vertical grid is 1, which is grid 1, and the horizontal grid is grid 2. Okay, and if you hover over it, it'll say set origin of the current grid 2. So that's how you can distinguish which is which when you're going in to set up different mullions for each. Okay, so let's reset this, and we can just wait. All right. Now, of course, probably looks a little weird. You'd want your mullions to align with the floor plate, and I'll get into how to do that a little bit later at another time. But for right now, just excuse me, just leave it how it is. So we have a curtain wall that's hosted to a face. We have a curtain system hosted to a face, and we have 2 basic walls. All our floors, and all of these are responsive to the conceptual mass that we created. So, I showed you how it updates. So once we have this geometry, what we can do, I'll show you a couple other things that you can do to manipulate the geometry that you'll need, right? So if you go in, you select the conceptual mass and edit in place, it'll bring this up. And since we have all of this other stuff kind of overlaid onto it, I'm going to highlight the entire thing and isolate it just so I can visually see it a little bit better with all the other stuff gone. And then I'm just going to start manipulating it a little bit. Get a little bit more of a funky geometry, and then let me show you. Let's see. It's a good thing to show you guys. So let me show you how to first. We still have it. Yeah, we still have a vertical face. So let me show you how to set a drawing plane. So right now we've been working just in like the level 1, drawing the base rectangle and extruding it up. But what if I wanted to draw a profile on this face so I can punch a hole through this building? To do that, what you want to do is go up to the top under the Modify tab is this work plane group, and there's a set work plane button that you can select. So if you select that, you can then select different faces of different elements. So I want to draw on this front face, so I make sure that it's highlighted in blue, go in, select it, so I click, and then it kind of just disappears. Doesn't really do much, but what happens is if I go to draw something, it's going to automatically, let's just draw a random thing. It's going to automatically draw on that face, right? So it's allowing you to draw in 3 dimensions, but unlike Rhino or SketchUp, you have to be a little bit more prescriptive with it and tell it exactly what plane you want to be drawing in. All right, so now that we have this funky shape, what we can do, 2 things. If we want to cut a hole through this, we can either go up to the top and create form again and extrude it through the building, and then use the cut tool, which is up at the top. And this is prominent throughout all of Revit. You can cut elements or join elements, walls, different ceilings to walls, or like different pieces of furniture, geometry. You can join them together or cut them with each other. But you can also do it here in the conceptual mass environment. So what I want to do is I want to cut, and then I want to cut through this element with this element. All right. And it's kind of, so the problem with, so you can do that, right? And it has cut through that element with this element. The problem is that you created it with another solid geometry. So that solid geometry stays in there, and you can delete it. But then all the geometry that the bigger geometry was referencing to cut through it is now gone. So what we want to do, and the better method of cutting through a conceptual mass is if we undo and go back to our 2D drawing on our face. If you go to create form and click the drop down, you'll be able to get this void form, and it comes through as this like kind of orange yellow geometry, and you can still manipulate it just like you would a solid geometry, but now it automatically defaults as a cutting tool. You don't have to go in and select cut up here. It automatically cuts through the geometry that it's intersecting with. It's probably a little easier to see stuff if we go down to our graphic display and turn it to shaded. There we go. A little bit easier to see what it's doing now. And then if we want to manipulate that stuff, we can just go in and tab through until we can select that void form. So the void form stays, but because it's a void form, it automatically disappears once it cuts through an object. And to access it again, you have to tab through until you highlight it. Okay? And then you can manipulate that as well. And you can now that you've cut through the conceptual mass, you can also go in and select the edges or faces of the mass. Ooh. And grab this little toggle. And that is the conceptual mass edge. It's currently invisible, but if you can tell, it's starting to manipulate how it cuts through this geometry. You can play around with that however you want. Let's see. Let's create some funky stuff. While we're on the topic of planes, there's another way, and probably a better way, to create a plane to draw on in 3 dimensions. It's a little bit more definitive and clear, and it's also not manipulative. So the problem with drawing on a face, and in some respects you can use it to your advantage, but the issue that can arise from drawing on a face is if that face changes, right? So I bring this face out 100 feet, then whatever was drawn on the face also gets moved with it. And so it loses its reference back here. So because I only extruded that void form the 120 feet to the other side, when I bring this mass face out 100 feet, it also brings the void form out, and it loses its cut through all the way because it's bringing that back face of the void form along with it. So just be aware of that. If we change this, if we change the angle and to the degree of which the conceptual mass face is aligned, it also starts to mess with whatever has been drawn on it. So just be aware of that. If you know that you want it to be in a certain place and remain there for the entirety of the project, the other thing that you can do is create a reference plane. And a reference plane, let's go in and delete this void for right now. Let's undo. You can either undo all the way back, or you can just tab through, select it, and delete it. So to create a reference plane, if you go back to the level 1, zoom out, up at the top, so here's that set work plane. To the left of that is draw, and to the left of that is a couple different reference tools. All right, so you have a model line, which essentially just creates a three-dimensional line that you can see throughout the project. The next one is a reference line. Now that will propagate throughout the entirety of the project, but it can't be used to draw on. So it's just a reference line. So if you have a grid, let's say a modular grid on your facade that you want a constant reference line for, you can use that, but you won't be able to use it as a drawing plane like you can reference plane. So that's what we're going to use right now. So if you click the reference plane and then go to approximately the midpoint of the mass, click and drag across. Doesn't matter how far, because this is a plane, so it's boundless. Yeah. You want to click and drag it all the way across, and then the next very crucial step is to name it. If you do not name it, it will not show up in the next couple steps in a drop down of the plane. So you need to name your plane if you want to utilize it as a reference point for a drawing. For drawing two-dimensional shapes. So click to name. And then just name it. Let's just name it center of mass. And then it will propagate that. And then what we can do then is go to our 3D view and go to set work plane. And instead of selecting or just highlighting over one of these planes, what you can do is up at the top left, underneath the properties in the draw, there's a little placement plane drop down. And if you do the drop down, it has every single plane that you can draw on that's been named, and it is established in the project, right? So all of our levels are technically planes. They're horizontal planes. And if you select them, then if you draw, it's going to automatically draw on level 8, right? But we don't want that. We want to draw on, if we go to set again, want to do a drop down and go down to our only reference plane right now in the project, and that's the center of mass reference plane. And then we can go and then draw, and I think, make sure that's selected. So the one thing about conceptual masses is if you they try and be they try and be clever. They try and be clever by allowing you to automatically draw on a surface if it can be used as a reference plane. So you see how if I just highlight or hover over these two walls, they automatically they highlight as planes that I can draw on, which is good and bad because it allows you to do that without setting a reference plane, but it also draw on face. Okay, so it allows you to draw on these faces pretty easily, but it also, if you want to be drawing on a certain plane, will prevent you, and you have to kind of do a workaround. And that workaround is if you go up and you click your drawing tool. This is just a typical line. To the right of that is draw on face or draw on the active work plane. So we want to change that from draw on face to draw on work plane so that it automatically will go to whatever reference plane we have selected, which is the center of mass. And then we can draw our void in the middle of it. Okay. Go in, and now it is based on that reference plane in the center of our project, and it will automatically update if we go in to our level 1 and move that reference plane. So if we move it back to the edge, if we go to our 3D view again and pan around, our line has updated to that edge. And then just like before, we can select it, create form, do a void form, create a cut through in our building. Okay, and then we can do this guy. Tab through, there we go. Tab through until we get our void, and then we can go in and we can select different elements of the void form that we want to manipulate. I like using the points. I don't know why, but all right. And then now that we've got a kind of crazy, funky form, we can go finish mass. All of our mass floors have updated. We can go down to our temporary hide isolate, click that and reset it. So all of those elements turn back on. And then what we can do is we could either go in and select all of these one by one, or we can do a bunch at one time by selecting everything, going up to the filter, and then let's do walls first. So select walls, update to face. Can't create mullions, it's okay, so just select through that. We only have the one roof, so we can just select that by itself, update to face. I don't know why this wall. So it cannot update. Is that true for the other one? No, that one updated. And then we can go in, select all of our floors by filtering through, check none, and just check floors, and then update those to the face. All right. It seems like I thought basic walls you could apply to. Huh. Oh, that's interesting. So if you had a wall, a basic wall hosted to a completely vertical face, and then you change that face to a non-true vertical wall, it won't update. But if you delete that existing basic wall, go in and reapply it, it will update. All right, then we can go in and change some of this stuff. And now we have, I mean, it looks like a hodgepodge of different things right now. But all of these elements are tied to our conceptual mass geometry. We can go and manipulate that geometry and then automatically update our Revit elements to that specific mass. And then you can go in and create all of your specific drawings for it. So I think some of our elevations are probably, we gotta drag this back. I think I've mentioned it before, but to be able to edit a elevation where we're taking our elevation from, you got to hit the arrow, not just the box. The box controls the elevation tag, the 2D elevation marker, but the triangle or arrow, whatever graphic it's showing up as, that controls the placement of it. And then we can move it back or forward depending on where our stuff is. And then if we go to our north elevation, turn on our shaded, we can see all of these are updated. Oh, it looks like west is getting cut through. Let's bring it back a little bit. There you go. But they don't look too, actually they don't look too impressive, but if we took a section cut through this guy, I bet it would look pretty cool. So you can start to get relatively complex geometry and then start to be able to produce your more traditional drawings from that complex geometry pretty easily. And that's the success of Revit. And that's why I'm showing you this conceptual massing environment to kind of illuminate the fact that you guys can use this for crazy, more complex forms that you may be producing in studio while still being able to utilize Revit as it's originally made for, which is construction document development. And you can create your floor plans, your sections, have all those things set up and be able to manipulate your form and change your design and have all of those drawings update so that you're not spending a week or two before your final review, hand drafting or manipulating line weights or whatever. You can have it all set up so you can be focusing that last 2 weeks on more important things like model making, rendering, or actually improving the design as a whole. So that's the conceptual massing environment. I don't think I missed anything. Yeah. So for your assignment, I'll go over at the beginning of class, but you'll be creating or recreating West 57 or Via by Bjarke Ingels. It's a pretty simple form, and it's pretty simple to generate using the conceptual mass tool. And then you're going to create some mass floors from that and then submit some drawings based on that form that you create. All right. Thanks. Have a good one.